It instead, as far as everything I've read so far, it's an online version, which means that it's not going to be the same as normal. The plan is that it'll be on May 5th, like it's always been scheduled to do, but it'll be an online version of it. And from what they have said so far, it's a 45-minute test, which I don't know how they're going to be able to gauge everything that you need to know from your AP class in 45 minutes on a test. I don't know. They haven't released any other information other than it's going to be a 45-minute online test that you do at home. That's all they've given us. So as soon as I know more stuff, you guys will know more stuff as well. Let's try another one. Let's try something a little bit more convoluted. Step it up a smidgen. I bet you're thinking, God, I have 3 weeks without hearing the word smidgen. Well, lo and behold, I found a way to get it in about 10 minutes into the video. Let's do x to the 5th plus 2x to the 3rd minus 8 times e to the 3x dx. I know what you're thinking. Let's go and just distribute it all through. You most certainly can. You can distribute it all through, but let's recall a couple of things. That when I distributed this through, and I were to get something like x to the 5th times e to the 3x, and we just focus on that one term right there, this thing would take us 5 different iterations of integrate by parts, right? That we would have to do something like let u equal x to the 5th, that way u prime can equal 5x to the 4th, v prime let that equal x 3 e to the 3x, and so on and so forth. And you'd have to do this up until this became 1 or a constant. That's 5 iterations of this. We could certainly do it, but I don't think I have that much film time, nor do I have enough board space, or do you have enough patience for that. So we're going to go ahead and use our tables instead. And that's just for that one portion. There you have to do it again for here, and luckily that one's not too bad. But not doing that. Instead, we're going to use table, let's see, which one should we use? It looks like we should probably use number 14 on table 3. Number 14. That one says that the integral of p of x times e to the ax dx is equal to, let's see, I'm going to get this up here. 1 over a of p of x times p of x times e to the ax minus the integral of, or 1 divided by a times the integral of, p prime of x times e to the ax dx. It's a lot like the integration by parts. So now, if we take that with here, in this case it's saying a function times e to the some coefficient times x. So if we correlate that to here, or corresponding to there, we would say that p of x is equal to that long polynomial, and that a would be equal to 3. And p of x being our function equal to the entire thing there, and then a being the part that corresponds with the coefficient of x. Now we plug everything in, the best that we can at least. So this will now become 1 over 3 times the original function times e to the ax, in this case e or a is 3, minus times the integral of the derivative of p, which is 5x to the fourth plus 6x squared, so that's 5x to the fourth plus 6x squared times e to the 3x dx. Now remember we were doing integration by parts before, and that we needed to take this portion here and save it off to the side. We have to do that here as well. Because now we have to do the same thing that we just did using that formula for that table for this portion here. Again, we could distribute this through if we wanted to, but we certainly don't have to. I don't want to use a second board because I don't want to move the camera. Okay, here's what I'm going to do. I'm going to write here. Let's go ahead and let another p of x equal 5x to the fourth plus 6x squared. Therefore, that p prime can equal 20x to the third plus 12x. And then a will still equal 3. I know I've talked a lot about having different functions, like having a p over here and having a p over here be different. In this case, for ease of sake, we don't have to make another board. Let's just do that. Okay, so now, as I take the integral of this guy, again, using that same formula that we used before, we'll recall that we have a negative 1/3 out in front of that, times 1 over a times p of x e to the 8x. That's another 1/3 times p of x, which is 5x to the fourth plus 6x squared times e to the 3x minus 1/3 times the integral of p prime of x times e to the 3x dx. I'll give you a moment to take a look at that. Pause the video if you need to. Okay, I've decided I just need to use 2 boards. In order to help you guys out, that's the best method. So I'm going to redo this part over here. I'm going to do it over here. Because we're going to have to do this a handful of times. Okay. So, let's reiterate what we did before we move on. We noticed in the very beginning, we had a function times e to the x. A function times e to the x relates us to table 3, number 14. It says a function times e to the x. The integral of that is this formula here. 1 over a times the function times e to the ax minus 1 over a times the integral of the derivative of that function times e to the x dx. Sounds like a lot, and it sort of is. But what we need to do is to find what p of x needed to be, which is what we did here. To find what a is, and that a is the corresponding coefficient of our exponent. We then plug everything into here. So that we came out with this 1/3 times the function times e to the 3x minus 1/3 times that integral. But we can't find this integral yet, we have to go ahead and use this again. Saying we have some function times e to the 3x. That is what we did up here. Defined that function. Found the derivative of that function, and then redefined what a needed to be. And so that's what we did here. We did the negative 1/3, which is what we had outside of our integral, times all of that. 1 over a times our function times e to the 3x minus 1 over a times the integral of the derivative of that function times e to the x. Now what I'm going to do, just for some ease, I'm going to go ahead and distribute that negative 1/3 in to give us negative 1/9 times 5x to the 4th plus 6x squared e to the 3x plus 1/9 times that integral. I don't have room for dx there, just imagine that it's there. So again, just like with integration by parts, we had individual pieces that we saved off to the side. We've already saved an a. Let's go ahead now and take this, save it as a b, because now we have another integral that we have to deal with. So we'll do that one here. We have p of x. Let's have that be 20x to the 3rd plus 12x. Therefore, p prime of x can equal 20 times 3, that's 60. X squared plus 12, and a will still continue to equal 3. So again, defining this to be p of x, doing the derivative of that, and then 3 is continuing to be a. And now we do the integral of it, meaning that we use the same exact formula over here. This has not changed. We've used that the entire time, or I guess this part of it. So that's 1 over a times p of x. Oh, sorry, we have that 1/9 out in front. Cannot forget about that. So 1 over a times p of x, which is 20x to the 3rd plus 12x times e to the 3x minus the integral of, 1 over 3 times the integral of 60x squared plus 12 times e to the 3x dx. Close off some parentheses. So the reason why I wanted to give us this problem is because it uses this over and over and over and over again, getting you used to what that is. And it's a lot, it's convoluted, there's a lot of things to deal with, I know, but trial by fire. Multiply in the 1/9, and luckily, as much as I hate online learning, the benefits of being able to pause a video when you're struggling, pretty paramount, I believe. At least with this. Minus 1/27 again, times that integral. And I'll move the camera over to the other board here in a second. We'll start working on that other integral. But as you notice, we're sort of like decreasing the powers of our function here. P of x started as x to the 5th, then went to the 4th, then to the 3rd. You've guessed it, it'll have to go to the 2nd, which it's about to now, then to the 1st, and then to the 0th. So we'll keep this as, I'm not going to call it c, because c always ends up in our formula anyways. We, of course, want to try our best to not use the same variable. And I will now move the camera. So our next little fella here is negative 1/27 times the integral of 60x squared plus 12 times e to the 3x dx. Well, just like before, we need to go ahead and define a p of x And luckily, p prime of x gets a little bit easier because we know we get rid of that constant. And a should still equal 3. So now as we, I guess you can't really see it over here, but that same formula we've been using, so we do negative 1/27 times 1 over a times the original function p of x times e to the 3x minus the integral of, I keep forgetting that 1/3, p prime of x, which is 120x times e to the 3x dx. Close my parentheses. Now if we're going to continue on, if you need to go ahead and pause it, rewatch that, you're more than welcome to. That is the power of getting to have 27, that's 101? No, it can't be 101. That's 90. 81? Positive 181 times my integral. And hold this over. And this be e. So now we're doing the integral of 1/81 times the integral well, you can certainly continue doing that. In fact, let's go ahead and use that same formula as we go along. I'm going to let p of x equal 120x. Therefore, that p prime is going to equal 120, giving us 181ths, and a will equal 3. 181ths, or 81sts, yeah, 181st times 1/3 times 120x e to the 3x minus 1/3, didn't forget, times the integral of 120 e to the 3x dx. Almost there. Distribute through. 81 times 3 is 3 plus 240. 243. Oop, I just touched my face. That's how you get the corona. I find that I touch my face a lot. Just like inadvertently. So, what we should start noticing now is that our p of x, as we make p of x this time, it now has a degree smaller than the exponent in our e to the x. Which is great, because that means that we're almost done. As long as this polynomial here, this function, has a less degree than the exponent, we are one step away. We need to go ahead and take this piece and save it off to the side. What letter do you want to use? You can't answer. F. Bring that last part down. We don't need a whole lot of room for this one. Although there are actually a number of ways you can do this one, you don't have to use this rule that we're going to use, but we need to get more and more comfortable with it. So we're going to let p of x equal 120, a equal 3, and you guessed it, p of x, when you do p prime of that, it's going to be 0. Congratulations. So now when you plug this into that formula, you won't have any integrals because the integral should be p prime times e to the 3x. Well, p prime is 0. So that's negative 243 times 1/3 times p of x e to the 3x minus the integral of 1/3 times, or of 0 times e to the 3x dx. Well, that cancels cancels out. So you just have 1/3 times 120 is 40? No. Yeah? Yeah, 40. So that's negative 40, 240 e to the 3x. And this is your last part. What comes after f? G? Sure. G. Gee willikers, Mr. McCabe. What a problem. Yeah, I know. It's a lot. It's a lot to take in. And I know I said at the very beginning of this, oh, this will be really easy. You'll love this. Not all of them are going to be this difficult. They're really not going to be. And in fact, if you take a look at the back of your book, that last page of tables, they would have given us not necessarily a shortcut, but they gave us like an abridged version of this, meaning that you can't see it. It's a stupid camera. All right. And yes, I know I'm wearing sweatpants today. They're comfortable. It's the apocalypse. It's fine. They're U of A sweatpants, so it's fine. They did an abridgment to this portion here. Meaning, they didn't write that as, or they didn't have to write that as an integral. Instead, they could write that as alternating signs. Here, I don't know if you can see that or not. But you can certainly use that. It's not an issue. So that means we have to take A, I shouldn't have clouded that, A, B, D, and on the other board, E, F, and G, and put them all together to give us one really long, obnoxious problem. But hey, let's not worry about that. Let's go ahead and write it down. Why not? Why the heck not? And you don't need this information. You can rewind. Nothing better than online learning. You can't ask me any questions. So that means we have to take A plus B plus D plus E plus F plus G. And here's what I'm going to do. In order to alleviate a number of this that it's just going to be fairly obnoxious, I'm going to go ahead and factor out an e to the 3x. And then you'll notice every single one of them has an e to the 3x in it, right? You can't see those ones, but they're in there too. So I'm going to write e to the 3x times a, which is 1/3 x to the 5th plus 2x to the 3rd minus 8. Then on to b, which is minus 1/9 times x, 5x to the 4th plus 6x squared plus 1/27 times 20x to the 3rd plus 12x. Then e, which is negative 1/81 times 60x squared plus 12. And then f, which is 1/243 times 120x plus g, which is negative negative 40 243 times, no, we can do the x there because we already did that part. Close your parentheses. This is A, B, D, E, F, G. And you're done. Except for Christian will already tell you that we're forgetting the most important part of all this. And the reason why we had to skip a letter there is because we have to, of course, add C. Whew! That was a pain in the tuchus. It took up most of my video time. That is fine. It's fine. We're all good here. I know it's difficult. I know it's a lot of stuff. I know it's a lot of stuff to deal with having to watch it on a computer instead of being here to ask me questions and to have me slow down, but You can always pause the video as much as you need. You can always text me while you're watching this to ask me questions. I hope to, because we got some time, right? We're gonna be chilling in the house and watching videos for a couple of weeks. I want to try to figure out a way to do a live stream, either through Zoom, Facebook Live. I don't know. There's so many more tech savvy people than me that they can figure something out for me to do a live stream for us. And we'll have a set time every day when we can do it, and that might be more beneficial.